first scheduled talk for this afternoon, and that's Guy Boistel. And he's gonna speak about the GEOS contribution to the study of classical Cepheids and long-term periodic variations.
Sound is good, yes. Okay. Good evening, ladies and gentlemen, and thank you to be here at the very advanced hour of the day with a very hard density of talks since this morning. My name is Guy Boistel. I'm co-secretary of the GEOS with Stéphane Ferrand. I'm also a historian of astronomy at Nantes University, and I'm responsible of the history of astronomy group of Centre François Viette with the Department of History of Science and Technology. I will talk about the contribution of the GEOS in the field of Cepheids observation. The observation of Cepheids is traditional since the foundation of the GEOS in 1974-75. We have two pillars of the GEOS here, Jean-Francois and Joseph Rémis, surtout. I'm a member of the GEOS till 1979. Due to an original philosophy of the GEOS of keeping our nodes circular for our eyes only, or for an internal diffusion only, GEOS has not reached the international visibility it deserves, and in particular on the question of Cepheids. I'm going to explain why and how our new project is to build an international Cepheids database of times of maximum. For that, we have to collect all available times of maxima of Cepheids, determined by all types of photometry, but this work required to start by collect the own production of the GEOS on Cepheids since its beginnings. Next. Where is yes. Why Cepheids? I won't develop that point. We have learned all the basics with Catherine Kohlenberg's brilliant talk. 3 points. The luminosity period relation, called now Miss Leavitt's relation. The second point is that Cepheids are pulsating stars and are parts of stellar evolution. They have an internal physics theory which demands to be developed. Third point, and this is a new trend in the geoscientific policy for the next years. During these 30 last years, new topics have been developed around Cepheids as to detect Cepheids binary systems, mixing results coming from spectrophotometry, radial velocities measurements, and long-term behavior of the ominous sea of a period of the Cepheids, as we are going to see in the next slides. The GEOS and the Cepheids. So the observation, as I said, in the GEOS begins with its foundation in the 1974-75 years by Alain Figère. I made some statistics, and we can see the sum up on that slide. We can collect 427 registered times of maximum for 56 Cepheids regularly observed, with a list of the highlighted stars on the panel. Where is the pointer? No, ça? Non, c'est pas ça. Oh, sorry. Oops. Thank you. Where is the pointer on the...
That's the pointer.
That's the pointer. Okay, thank you very much. To go back. Yeah. Pointer. Okay. We have the highlighted stars of a GEOS observing routing program, and I will speak about. Okay. The real number of time of maximum collected is certainly underestimated. A lot of series of our observations are still not processed, even in my own notebooks. In GEOS 2, many observations were not processed. The original philosophy of this group being that everyone is responsible for his or her observations. There is no culture of hierarchical centralization of data as in most other groups. This philosophical posture has its advantages and disadvantages. One of the major disadvantages has been a lack of visibility of the actual output of the group. So the international underrepresentation of the group in the field of Cepheids observation is particularly glaring. I came back to GEOS and variable star observations because of a lockdown during COVID epidemic. When I temporarily stopped my observations in 1992-93, my own program turned to a renewal of Cepheids observations inside the GEOS with a new program of faint Cepheids observed with my homemade 12-inch telescope, and the will to collect more and more times of maximum instead of studying the wave shape of our visual light curve again and again. We know all the alias and bias in our visual light curves. It is a useful activity for individual improvement, but a very limited scope in comparison with the increasing production of photometric observations. I'm very proud to have convinced my friend in the Bureau of the GEOS to put our international publication of scientific interest, such as the Note Circulaire on Cepheids, in open access online when I returned in 2020. You can now access these studies, these fruitful studies on the GEOS website, as shown at the bottom of the slide. We have a new rubric, Note Circulaire Open Access. And you have some example here. Yes. So I've put together a number of results published and scattered in all GEOS monthly reports that still remain for internal use in two open access Note Circulaire published in early 23. The Note Circulaire 1324 and 1325. For example, you can see a part of his atlas of high-quality visual light curves obtained at GEOS during the years 1975-76 for those projected here. We used to compute mean light curve on beams of 0.05 period shift by 0.05 period, and you can see the results of this process on the slide. Normally, it is supposed to be the first wow effect. No? Well, sorry. I continue. There are about 70 publications on Cepheids between 1976 and now. From these publications, about 500 times of maximum have been extracted, as I mentioned before. I also rediscovered the dynamic I was in when I when I came back during the COVID lockdown, dynamic reinforced by the availability of thousands of photometric data made accessible by the automatic telescope servers, and in particular those of the EVSO. VS6, the variable star index, is a very powerful interface. But we have also the McMaster Cepheids database of Berdnikov, which make available the observations of a large publication of Zabados, Mitchell, and all the authors which published photometric data during the years 1960, 1990. Unfortunately, this database is no more maintained. I also found that the German BAV data were still not very used by the collective Cepheid publications. The BAV as a data for scientists service that assembles in an Excel file a large set of Cepheids, times of maximum, scattered in their own publications and elsewhere. The first results of upgrading and regrouping the available visual observations of GEOS and BAV is our traditional refereed publications, the GEOS Circular, articles submitted to a referee among GEOS Pro astronomers on SV vulpecula, classical Cepheid, and I collected 338 times of maximum, and this beautiful parabola. I also show on the slide my own visual light curve obtained in 2022, and that indicates the strength of visual observations for long period Cepheids when we can make a good survey with good meteorology. SVVUL is a member of a cluster and it is in an advanced phase of its evolution. The irregular variation of the ominous sea with an amplitude of 5 or 6 days around the parabola pose an obvious theoretical problem not solved yet. With this GEOS Circular on Cepheid, number 3, we at the GEOS also inaugurate the open access online publication of the data in 3 formats, as you can see at the middle of the slide. Excel, .csv, and .txt of the data that were used for these studies as a modern publication in astronomy, astrophysics. Another case study published in early 2023, the classical Cepheid RTO, RT Aurigae. On your upper right corner, you can see different interpretations of the variations of the ominous sea for the classical, for that classical Cepheid, mostly based on incomplete set of times of maximum published in the scientific literature. But the abstract service of the NASA, ADS, bibliographic facility, now makes available high-quality visual observations of Cepheid from the 1880s onwards. You just have to take the time to process them. Automatic servers such as the Japanese KWS do not process the measurements. They must also be processed. I also used the EVSO databases via VS6 server or the software VStar. Here too, many observations of the EVSO are still not processed. And we have to finish the reduction to obtain times of maximum. Finally, on a very large time scale and taking into account the contribution from GEOS and BAV to the period of RT or Aurigae decreases steadily in the ephemeris, only needs to be corrected. The interpretation is here very simple. The behavior of a long-scale ominous diagrams seems to show a sinusoidal variation which could be related to the binarity of a system. I won't develop that because Raymond Matt tomorrow will present this part of the explanation of variations of ominous diagrams. So, I am working at the time on an extended list of Cepheids, including W. geminorum, RY Cassiope, and V. lacerta. We have a visual priority program of 17 Cepheids at the GEOS now, but many of the visual observers have their own Cepheids program. You can see on the table the duration of temporal coverage that can be processed for these free Cepheids. For V. lacerta, the first exploitable times of maximum even goes back to 1873. So we can see the curves for W gem. At the top of the slide, you can see the different interpretations of the ominous diagram made by Zabados in 1980 and 1981 on an incomplete set of data. As with SVVU and RT Auriga, the diagram showing the origin of the sources here reinforce the need to take into account the visual observations performed. Remember that until the 1940s, most of the available measurements were visual or photovisual, as if to say a visual estimation of the brightness of a variable on photographic plates by comparison. The actual diagram I obtained, here, I've compiled is quite clear. The period decreases with a quadratic term. The diagram of the quadratic residuals does not show anything particular except the natural discrepancy of the times of maximum, whatever the photometry used. In the end, the interpretation of W. Geminorum's ominous diagram is also quite simple here. Some results which to be published in the next weeks. The first exploitation of observation extended to all those available is to complete the ominous diagrams and to determine the period variation rates in seconds per year, as this indicator is given in today's publications. The table sums up the results obtained for these three classical Cepheids, and you will be able to read that on the GEOS server in the next weeks. So, in this new perspective of a new scientific policy of the GEOS, our chairman, dear chairman Jean-Francois, who already maintained the international database of the auroral array, proposed to do the same thing with the Cepheids, taking advantage of the handing over of a BAV database, by its president, Leonard Pagel, at the beginning of this year. He gave us a list of 7,000 times of max. And Jean-Francois integrate that database in a database in progress. So we can, if you are familiar with the auroral array database, the interface is exactly the same. we enter the name of the star on the right of the panel, and we have the elements here, and in the bottom the database generates the ominous C diagram, and you have the list of the times of maximum and the ominous C computed on the elements you gave in the database. There is a column called period shift, and we have to enter manually the period shift. As you can see here, this period shift has to be set for as the rule for the elements used to compute this ominous C diagram. Another example, WGEM, the BAV database give here 112 max, but in the times of maximum, in the next publication of the GEOS, I have the double number. Okay, just a word about the BAV database. It is based on the compilation and the incredible work realized by Ralph Meyer in 2007 and published in the BAV journal. Unfortunately, without an explanation, Ralph Meyer sometimes truncated times of maximum by keeping only 2 decimal places, even on times of maximum determined by Cepheids photometry with an higher precision, and by modifying data published in the literature, notably in the classic Zabados studies from 1977 to 1991. It is then necessary to check everything again and again, which increases the time needed to make this database available. So I'm very on time. Yeah, conclusion. To the philosophy, the original philosophy of GEOS, we had the new component of seizing the automatic data and to widen the basis of the available data to feed this very new base of instance of maximum ominous C Cepheids, as shown previously. Visual observations carefully made by skilled and regular observers are always of added value and are often competitive with CCD observations, and notably for long period Cepheids with sufficient amplitude. I've shown in the GEOS circular on SVVUL that the precision of the times of maximum determined by visual observations, estimates if you want, and CCD observations is the same, 1.5 days in average. Many Cepheids remained under-observed, and there is room for amateurs to produce high-quality studies, visual or CCD photometry. The calls for pro-am collaboration remained relevant since the story called by Argelander in 1844 in Schumacher-Jahrbuch for the famous Aufforderung an Freunde der Astronomie, and it's relayed by John Percy in 2021 in the GIF, in the journal of the AVSO, about a study of the Cepheid RU Camelopardies. Thank you for listening to my presentation at this late hour of this already long and dense day.
Thank you very much for the presentation. So I think we have plenty of time for some questions. Your presentation was too good. Oh, yes.
Thank you for your presentation. So I gather you are building the database of maxima. Do you also accept raw photometry without being the maximum established, or you just want to the maximum point into your database?
In fact, it depends on the available data. Someone we have all the light curve, so I reprocessed the computation of the time of maximum to check. Someone, I was on time. Sometimes we have only in the literature the times of maxima, so we must trust to this data. The filter is the luminosity diagram. When the average is on a parabola and you have a point have more than 3 sigma, so this is a bad point.
Oh, okay, thank you.
Any other questions? No, then let's thank the speaker again.
Thank you very much.
Our next speaker is